Seb, thanks very much for joining us on this episode of the Life Sciences podcast by Barrington James. I appreciate you taking time out from your own podcast, of course, the New Quantum Era, which has episodes launched weekly, right?
Pretty much, yeah. It has been. It was bi-weekly initially, and we've been weekly for the last month or so. Yeah, trying to keep it more frequent.
Yeah, I suppose that's not much of a chore, right? It's something you want to do, so it just becomes
That's
natural.
right. That's right. I mean, it was born of a desire to talk with more researchers, actually, because I find that just the best part of this job is being able to interact with scientists, and so it really is. We talk to a different quantum researcher in each episode, and it's focused on either applications of quantum technologies or their work within trying to make quantum computers and quantum networking work better. So it's great.
No, I can very much relate to that. So, people often ask me what I do, and rather than try and explain it, I just say I talk to people far cleverer than me who are trying to solve really important problems.
Yeah.
Simple as
that. Exactly. Yeah.
So, for those of you who don't know who might be watching, Seb, I believe your title is the worldwide go-to-market strategy for AWS. Is that right?
That's right. Yeah. Well, quantum technologies for AWS, not all of it, just that narrow piece of it.
Yeah, just that small section.
That's right.
So, we spoke before, and what's really interesting to me is we've touched on in previous conversations. Your background, you've always kind of been on that cusp of the cutting edge, and really, in technology from. I don't want to say it's innovation, but certainly from the kind of dawn of the internet in the way that I would understand it. And people of my age. So I think you've got a lot of interesting experience, and I'm keen just to kind of talk through some of that and see if there's parallels that we can draw from your various experiences. But just to frame the conversation, I thought I'd give a kind of brief overview of some of the roles that you have, because I think it's quite an interesting litany if you reel them off from your LinkedIn. So you were the founder for the customer web support at Apple. Then you went on to be a senior strategist at IBM for 5-6 years. Then you went into a senior business development role for Oracle. Then you went to be CEO of a tech propulsion laboratory, I think was the title of the company, and that was in Vietnam. Then there was COO of Brewbot, and then back to IBM for various different roles, and then currently to Amazon. So that's quite a litany of experiences that you've got there.
Yeah, I mean, it drops out a bunch of side projects where I got involved in early stage startups and sort of, help them foster along to see if maybe I might leave full time, which none of them, they turned out to be consulting gigs and that sort of thing on the side. But I also founded 2 different ISPs. I like to say I founded one internet service provider too early, and then the second one too late. So I missed out on the whole .com gold rush, unfortunately.
Well, I mean, let's dive into that a little bit, because you mentioned the .com gold rush. You obviously had some pretty good insight to that in your role as the founder of Apple's web support development team. So
the internet version of that. So I joined Apple support out of college. And in part because I wanted to get out of Canada and get closer to. I grew up in Canada. I wanted to get to the States. I was born in the States, so I had dual citizenship, which gave me an advantage. And I wanted to get closer to where the early days of the internet was actually starting to get commercialized, because Canada was quite a bit further back. That's where I founded my first ISP and realized, oh, there's no commercial opportunity here whatsoever. The job at Apple opened up. I moved to Austin, and very quickly, tech support on the phone is grueling and punishing and stressful. And we were, a couple of us started wondering if there was a way at that point. When 80% of the calls, someone would say, my printer stopped working, you'd say, well, you need a new printer driver, give me your address. We would burn a CD-ROM on our machine underneath our desk, drop it in a FedEx envelope, and then ship it off to them overnight.
Wow.
That felt inefficient. And so we, as a Skunkworks project, we commandeered a Unix machine that another group had for supporting Apple's NFS product. Apple shared an NFS product, which they weren't really using. So we grabbed that and stuffed it in a closet. They never even noticed it was gone. And we set up a website where we had the Apple software updates and the tech info library that we were using to search for the solution to customers' problems in the first place. So we launched this interactive customer support website, and very quickly, obviously, we were in the top 10 most trafficked websites for a few months because there weren't that many websites. This is 94 or 95, somewhere around there. So that was really, it was a classic sort of scratching your own itch situation, right? We were really sick of answering the same calls over and over and over again, and pitched to our management like, if we build this thing, we think we can eliminate a bunch of the calls out of the queue, and it worked.
So, I mean, what does pitching that at Apple look like at that time? Because I mean, as I said, Apple now for me is a company that I've grown up with as the biggest name in the household. In 1994, I imagine that's slightly different. So, what's the dynamic
Well,
like?
I mean, it was definitely, a leading company, but the there was questions about its long-term prospects, right? I mean, it was something like 4% of market share, and in many ways getting squeezed by Microsoft in the business domain, and still strong in the education space, but there really wasn't as big a consumer space at this point. It was still sort of a hobbyist thing to have a computer at home, rather than just a necessity. So there was concern about the company long term, but it was still a large and a going concern. But the support organization was just a pure cost center. It was, Cupertino was very, very far away from us. We were in Austin, Texas. I think accounts payable and support were the only two divisions that had offices in Austin, so you can see where they sort of ranked us, right?
Yeah.
Um, and so we actually had a single leased line that our customer relation management, like our call management software, ran on back to the servers on Cupertino. So in Cupertino, so it was sort of a very slow backhaul back to Cupertino. So the long story short, we basically had to just sort of carve out this Skunkworks project. We didn't really ask for permission, is what I'm trying to say. We just we did it. We just did it locally. And by the time IT realized what we were doing, we had one of the most trafficked websites in the world. And we got called on the carpet in a meeting, and I just brought one chart, which was the stack of CDs that we hadn't shipped out each month, basically.
Yeah, it's a pretty efficient chart for demonstrating some value.
Ended that conversation pretty quickly, yeah.
Yeah, I can imagine. And how innovative is that within its top period, right? I mean, are you kind of the first support team of that kind, as far as you know?
Absolutely. Yeah, definitely the first customer support website. I mean, to give you some indication, at one point I wrote a script to help us, sort of edit content on the page, which was basically would allow you to look at the source of the page and edit it right in place, and then reload the web page and upload it, or refresh it right there, which basically is a wiki. And like that was about 5 years before the first wiki was created, and certainly long before Wikipedia was around. So everything we were doing was a first. We were just inventing it as we went along, basically. And that's, I mean, really, you said like sort of bouncing from one sort of bleeding edge to another. That's what I look for, is like, do we have any idea how to solve this problem? Do we know what the problem is? No? Good. That's what I want to do next.
Yeah. Challenge is opportunity, somebody once said to me, and I think you embody it quite a lot, and that seems to be your mindset. I don't want to put words in your mouth, but I think
no, it's true. I mean, it's my own version of attention deficit disorder, really. I mean, if it's a solved problem, I'm not that interested in it. If there isn't a solution, or even if you haven't identified the right problem to really tackle, that's when I'm the most interested.
Well, I mean, that speaks a lot as to how you've ended up in quantum computing, but we can come on to that.
Yeah, I mean, it's the most bleeding edge I've ever encountered, and probably ever will encounter, right? I mean, that was really my first encounter with quantum was at an IBM summit in December of 2017. They were announcing the launch of their 53 qubit machine coming in the next year. They were sort of saying, this is our plan. And they had a bunch of, the pioneers of the field giving talks. And I actually went in my role as uh, developer advocacy strategy, basically. I had been doing business partnerships with things like NPM and the Hadoop community and other communities that had large numbers of open source developers. And so they were asking sort of for help and an outside perspective on their developer strategy for what would be Qiskit. It wasn't Qiskit yet. I guess they had launched Qiskit, but they didn't have a Qiskit.org up yet. And so I attended from that perspective. What I saw was like, you know, quantum physicists and computer scientists up on stage talking about these natural phenomena, natural behaviors that could support computation that might be able to do things faster than any computer could otherwise do. And it was, I mean, mind blowing is an overused phrase, but it was mind blowing. I mean, it felt like a reset of the clock to 1950 something, right? Pre-transistor, pre-microprocessor. And that was, it was catnip for me. There was no way I was going to do anything but that at that point.
Yeah. Yeah, the transistor piece is interesting because I think that, people often talk to me and ask me about, where do I think that transistor moment is going to come in quantum computing? I'm not so sure. I don't know if we'll have like a definitive, like, okay, we've done it, or that's been created. And I think it's going to be a bit more of a up and down path.
Yeah. I mean, history doesn't repeat, but it rhymes, right? Like there won't be a transistor per se, but if you look at what the breakthrough that the transistor represented, it was really the beginning. And I don't think necessarily there was an immediate recognition of what that was going to bring, right? It was just this became a path to cheaper to manufacture, more abundant, smaller scale components, and therefore you could build more complex devices, more reliable devices. And so it was an important kind of step along the way, but it wasn't like suddenly, the clouds parted and there was lightning and everyone went, the transistor, whatever.
That's a good point.
I kind of say like maybe we've already had the transistor moment because we only say the transistor moment 70 years afterwards, right?
That's a good point. Yeah. So I want to just go back to the role at Apple a little bit, and we've jumped forward in time scale. So you're 1994. You found the online customer support team. How does that then kind of evolve and grow? And at what point do you leave Apple? And what's the situation when you do so?
Yeah, I left about 3 years later. Again, it was sort of, a solved problem. I mean, it started to become, more standard business process. Like, we've got to create new content for the new product, and here's a content production pipeline, and how do you update the website and all that operational stuff, like, I mean, I know it is a vital role. I love the fact that I have friends and colleagues, and I've worked with people who love to do that stuff and to make a really nicely engineered, abstract or physical machine run really well, right? But it's not my skill set. It's much more like I do the crazy sketch that, that you have to sort of look at and go, I guess that could work, right?
Yeah.
But so, it was really a matter of that. I left and I joined Tivoli, which had just been got acquired by IBM in 97. And I think 96. And I joined it 18 months later or something like that. One of the many instances of bad timing on my part post acquisition. But they were building, so Tivoli was a systems management business. And they were sort of doing two things post acquisition. One was building better tools for managing the rest of IBM's existing portfolio, but they had hired a CTO, Tom Bishop, who had done a stint at Bell Labs, and he believed very much in sort of inventing your own competition, right? So the internet was new; it was barely used in the enterprise at all, and so I was brought in to help them start thinking about systems management from an internet perspective. And really, I joked that the first, quarter or so, was me explaining what a firewall was to their engineering teams, because they were like, what do you mean outside of the corporate network? That doesn't make any sense. Why would you ever go out there, right?
Yeah. Yeah. Yeah.
so so that was fun. I mean, it sort of culminated for me in a project I did where we sort of made a prototype, or an MVP, you'd call it now. You didn't call it back then an MVP, but of a protocol for systems management. We called management tone, and it was essentially just a HTTP based protocol for describing system resources that you wanted to manage and what you wanted them to do, basically. So it looked a lot like what XML turned into. So it was, again, sort of like recognizing that HTTP was a great starting point, but there was a lot of additional application kind of functionality you could build into an extensible text-based format like that.
Okay. Okay. So again, really kind of cutting edge, right on the cusp of what has been possible and doing something innovative and new. It seems to be like, very, was that always deliberate for you? Have you always looked for that? Or are you looking back now and going, I can see the pattern?
I mean, it's deliberate in the sense of, if I don't have challenges, I start to get very unmotivated, and I don't like feeling
Your feet.
unmotivated. Yeah, I need something to wake me up in the morning, going like, what am I going to do about that?
Yeah, yeah, yeah.
So without those big challenges, I start to look for something to occupy myself. The unfortunate thing, I mean, it's funny. I think as a manager, and as an employer, it's always surprising to me that that's not something that you recognize as a like, that person's getting bored. Give them, what's our hardest problem to solve? Throw them into
Mm-hmm.
that, right? I've
Mm-hmm.
had to look outside of the company I was working for a new challenge, because there's that. It's sort of like, in a way, it goes hand in hand with like the Peter principle, right? You get sort of promoted to your point of incompetence.
Mm-hmm.
The flip side of that is, if you solve a problem, nobody wants you to go anywhere. It's just keep doing that, right? And it's like,
Yeah.
well, but there are better people to make that work better than I can. I need to go find some other unknown space and try to make some sense out of it, right? So
Mm-hmm. Mm-hmm.
but that's organizational skills, or culture of that type is very hard to come by and very hard to create from scratch. Sure.
Mm-hmm. I mean, look, I think you touch on on a wider point, an interesting thing there about retention of staff and how do you keep
Yeah,
people motivated. And I think that is something we don't see enough, is that change in department or in, because you can do several functions in the same business and it can feel like a new job for that
that's right.
person and the business
Absolutely.
still retain the skill set. And it doesn't mean
Yeah,
that, like, just to give an example, you could have moved on within Apple, but still been able to
that's
be
right.
on a call with the support team or whatever, and still
Yeah,
had that knowledge in house. And I think
that's
that's
right.
something, when we speak to our clients, it's something we always encourage, is making sure that you maximize the employees that you
That's
have
right.
on board before looking at what you can do
Yeah,
externally.
yeah,
So yeah, that's an interesting point. How would you, as a manager, look for that in somebody? Is there kind of key things that you see?
yeah. I mean, it is tricky, obviously, just sort of gauging motivation and check-ins, like how are you feeling about your work, that kind of stuff. That's, sort of table stakes. It's more, I think, like I said, there's some people who want a complete blank sheet of paper. There's other people who want, they want to take something that's existing and make it much better, right? There's people who have, there's different sets of skills, basically, and I think that's there's that sort of truism about employees aren't necessarily motivated by just more money, right?
Mm-hmm. Mm-hmm.
And I think that's true, but the trick is, okay, so what are they motivated by? Because no two people have exactly the same sort of intrinsic interests.
Mm-hmm.
So whatever, I mean, I think the challenge is to engage an employee in a way that helps you understand what it is that actually does get them out of bed in the morning, and then throw that stuff at them. I mean, the I do think that there's too much sort of risk aversion, right? Of like, there's a feeling like, okay, this is work. If it's not broke, don't fix it, right? This part of the business is running fine. Why would I swap people in and out because I'm just going to put that
Yep.
at risk? I think organizational capabilities are more resilient than that. As you said, like you move somebody out, they're still there as a resource, right? And they
Yeah.
still will have some kind of ownership stake in that thing that they help build. So they're going to, be keeping an eye on it and going like, oh, you seem to be doing, you forgot this one thing that we really, learned a
Yeah.
few years ago or whatever, right? So I don't know. I think, you know, to me, the most valuable thing that humans in general have is an ability to learn new stuff. And I think any opportunity to learn, and people who are drawn to opportunities to learn are the most valuable assets to an organization by
Mm.
far.
That's interesting. I mean, look, we could get on a real side tangent here, but how? I mean, so two things, right? One, a teacher once said to me, "The day you stop learning is the day you start dying," and
Yeah,
that's quite deep. And at the time, I never really understood it, but it's something that stuck with me. And the older I get, the more that kind of plays into my thinking, and I do make a
yeah.
conscious effort to keep trying to learn and evolve. Um, Two, and this, as I said, could get us in a dangerous tangent, but I'm sure
I
you saw
love dangerous tangents.
yeah, me too. It's a bit of a fallacy.
Yeah,
So I'm sure you would have seen the Chat GPT 4.0 announcement
yes,
yesterday. So how do you pair the idea that learning is imperative to human nature against the idea that we're going to have personalized LLMs that are your own kind of source of a data bank, if
right.
you will, and will answer all your questions for you? How do you see those two kind of playing out?
Yeah, I mean, um, what my hope is that we use these things like calculators, right? We don't have to be able to do giant, long division and multiplication of giant numbers on paper with a pencil for minutes at a time. We punch the numbers in, we hit equals, and we get the answer. That doesn't mean we don't understand how it's doing it. It doesn't mean we can't do that if we had to ourselves. And that's what ultimately I hope that LLMs just allow us to I mean, I'm writing a book right now, and I'm using an LLM to help with research, and it feels a lot like having a conversation with a Wikipedia, right? Like I ask it, whatever, what are three mid 20th century innovations, technological innovations that came about because of new understanding of physics, right? And it came up with radar and what was it? I can't remember the other nuclear magnetic resonance. I think was a little later, but anyway, it came up with a nice set of three. And the great thing is the tools are getting better at giving you references. So it's like, here's my three, candidates to answer your question, and here's where I found that information.
Yeah.
So I go back and I back check, but that saved me whatever 15, 20 minutes or something like that, right? And that adds up. So I think it's just a matter. Just it's not answering all your questions for you. It's answering some questions so you can focus on other ones, right? So it's doing the grunt work and the. I mean, I don't think they actually are a threat to creativity in any way, shape, or form. I think that's sort of the faddish nature of them right now. We're thinking, oh, they can do art. No, they can't do art at all. What they're doing is pastiche, which is taking a bunch of human art and just mushing it all together, right? That's not actually art. So what it could do is allow an artist to create something that would be very, very difficult to do with physical medium, right? Or also, it may just automate boring stuff in their life so they can focus more on making something really amazing with physical medium. I think that it's, all of the tools we make are ultimately trying to, enhance and augment the human capabilities and human experience. So, we always have a panic when a major new technology comes along, and then we figure it out, and as long as it's working well, that's the biggest problem we have. The more augmented we are by technologies, the more we're plagued by the technologies sort of failing us. But that's always the case. But yeah,
Yeah.
I mean, it's another tool basically. It's the simple version of that answer.
No, I think that's a very good answer, and I think that's something that a lot of people would want to hear. I think the kind of fear factor is that it becomes more than a tool, right? And that's the
Yeah,
general kind of scare for people. But yeah, I tend to agree. I think as long as it's utilized in the right way, it is like any other tool. The key though is about education and making sure that
yeah,
people are able to use that in the right way and they have access
yes,
to it in the first place to be able to do so.
that's
And
true.
the reason I was thinking about this, my friend who's shout out to Rob Bunker. He's one of my best friends, but he's into cybersecurity and he works in that space. And we were having a conversation yesterday. And he's just had, he's a recent father, and he was saying, what is my kid going to do at school? Like, what is he going to learn? And the kind of conversation we were having is that, our parents would always say to us, oh, we didn't have the internet. And we fear that we're going to be the guys who go like, oh, we didn't have LLMs. You don't know how hard it was. We can kind of see that full cycle happening.
Totally. That's a challenge to the educational system, though. I mean, and, step one is we have to start investing in the educational system again, because we haven't been for decades, right? We've been disinvesting, but that shows, right? Because I mean, kids are, they're being asked to learn math or any other topic the way it was learned in the 1950s or 60s or 70s or maybe 80s, but like, that's ridiculous, right? Like to still be grinding through the same kind of rote learning and, building the skills that the workforce needs from the middle of last century. It's like,
exactly.
why? I mean, I think that the good thing is, I think that in many ways, the best models of education I've seen have been very child directed, right? It's like, what is the kid interested in? Because we're born with infinite curiosity and infinite desire to learn. So as long as you don't get in the way or like crush that in some way, we're learning machines, right? So the idea of things like subjects, I think, needs to go out the window. It's like, why are these separate domains? They really aren't, right? They're all the same. They're in this overarching kind of search for meaning and for tools to expand capabilities and understanding. Why would you separate one from the other? If you happen to be coming at this from a mathematical perspective or a physics perspective or a humanities perspective at this given time, it's all the same, systems of understanding ultimately. So I think that's that kind of boundaryless kind of learning that's driven by the child is much easier to enable with personalized technological tools than one teacher in a classroom of 30 kids all going in 30 different directions.
Yeah, no, I can see that. I think that's a good point. I think that the challenge for, it potentially logistically prescriptive learning is a little bit easier, right?
It
than
is.
having kids wanting to do their own thing. But that, easy doesn't mean it's the right thing to do.
Right.
The best analogy I had for learning came from Elon Musk, actually. And I don't know much of it. Obviously, he has the homeschooling thing going on and whatever. But his general point, and I'm just going to paraphrase, was that, school is the only place in the world where you will go and somebody who says, here's all the answers, now tell me how I figured that out, right? In every other situation in life, you go to the problem and go, oh, how do I fix that? What do I need to do? What are my solutions?
Right.
School is the only situation in our experience where you're given all the answers and then told, right, now figure it out. And that just doesn't make sense given our own, experiences. Right. And that was again, a point that stuck with me when he said it. And I'm paraphrasing, but it was thing.
No, that's what I mean by rote learning, right? It's like just receive these facts as given and memorize them and be able to spit them back without understanding, why are you even bothering to tell me this stuff?
Yeah. Okay, so as I said, dangerous tangent we've gone on there.
I mean, it's related. It's definitely related. I mean, if you're trying to pull it back to quantum technologies, there's a lot of concepts in there that are very, very tightly related.
So give me a kind of, crash course then of your next 10 years. You've left Apple, and then you guys, as I said at the start, you kind of had this really interesting journey with a few various different titles. What I would say is very atypical, Seb, of people that I come across in quantum. So just talk me through that.
Very true. Yeah. So, I mean, I guess the unifying theme, as it were, is again, it's this sort of trying to problem solve, right? Trying to wade into a space where there isn't certainty even about the right answers, the right questions to ask, let alone the answers to those questions. So from IBM, I had a number of different roles. I actually did sort of like product and market strategy for an emerging business opportunity within an IBM. So it was one of their incubated kind of businesses, which was called pervasive computing. at the time, which just basically meant anywhere where the client wasn't a desktop PC or a laptop. So mobile computing, computing in cars, IoT, things like that that didn't have names yet, which was fun, but didn't result in a lot of product launches. There was a lot of interesting projects, but the I guess the best thing out of that was I wrote a white paper in about 2001, about essentially my proposal was that we take Linux and the integrated micro devices division at IBM and create an open specification for a mobile PC, essentially like a handheld PC, which essentially was Android about 10 or 15 years before there
Yeah,
was
right.
Android. And it went up to Stan Palmisano as the CEO, and he had nice words to say about it, but they never did anything with it. And that's kind of why I ended up leaving IBM eventually. So then I tried to do something a little bit more customer engaged, field engaged with Oracle. So I built a solution business for Oracle, where so Oracle had a very license driven sales model at the time. It was basically how many database licenses do you want? And it had nothing to do with the business problem the customer was trying to solve. So we built a solution business that essentially educated the Oracle sales on how IBM sold to customers by selling Oracle software on IBM hardware to banks, essentially. Because we had a lot of overlap in the customer base. Lots of banks used Oracle databases, but Oracle knew nothing about how they were being used. IBM had a lot of financial services customers and also knew a lot about their business. So it was sort of a way to increase Oracle's sort of sales intelligence, I guess, which I learned a lot. I mean, it was about building sales plays and enabling a field, and what really works with a customer engagement, like as on a one-to-one basis, but also to build a program out of that. So it was really interesting. And then, as I said, there were sort of startups in between all of these things. So I guess the next thing would have been Tech Propulsion Labs. So there, the iPhone had happened. Mobile apps were sort of the big thing. I'd gone to business school. I went to Columbia and London Business School in a joint program, and all of my classmates had business backgrounds, and they were saying, "Oh, you're a technologist. I've got this great idea for a mobile app, and I don't know how to build it." So some friends of mine had started investing in businesses in Vietnam. One was Vietnamese, and he brought some friends over to help him build a business or an investment portfolio there. And we noticed that there was really good programming skills in Vietnam, but not a lot of interesting jobs. Like a lot of their jobs for programmers were just outsourced, very utility programming. And it seemed like there was, we could scoop up a lot of the best talent in the country by just giving them more interesting jobs. Like that's back to, what are people motivated by? Developers, the best developers are motivated by like cool like projects, right? Like if you can give them something really cool to work on, they'll do it for free.
Yeah.
Because they're puzzle solvers, right? They love puzzles. So you give them a bunch of interesting puzzles to solve, and they're happy. So we built that as that model. Essentially, it was sort of Western customers with no technology capability who had a business idea, and we would build an MVP for them essentially and get them
Okay.
cheaper cost of capital for their seed investment or A round or whatever, so they could start to actually get investment, go find a tech co-founder, and we would sort of transition the initial code base into their dev team or be their outsourced dev team longer term. So that was fun. That was interesting. Lots of consultative selling in the US and in Europe. Mostly small, medium business, early stage startups, but some enterprise as well, which was fun, just crossing a lot of those sort of spaces. And then I guess I went to, there was a little bit of bouncing around in there, but then the Brewbot thing, they had just gone through Techstars in Austin. and they built a prototype of this beer brewing appliance, smart appliance. And they had kind of gone to the school of Google engineering. They were designers and they cobbled together this prototype. So I took the COO role so I could help them build an engineering team, basically. So I hired the first, like the chief scientist, and because there actually was some real science to do, because it's basically controlled chemical reaction over time.
Yeah.
Um, and and then the engineer was from an electric motorcycle company here in the Bay Area. They were based in Belfast, so it was sort of
That's
an
also ahead of
international.
its time.
What's that? Oh,
Electric
electric
motorcycle.
motorcycle? Yeah. Yeah. Yes, definitely. Anyway, so it was fun. I mean, I think for me, what happened was there was a better product market fit in the commercial space as a rapid prototyper for craft breweries, and as a way to get a cheaper liquor license for a restaurant in California. Because if you brew beer on premise, you can get a brew pub license instead of the full license, which
Yeah.
yeah, so I was really keen on the commercial side of things. The founder was more keen on the consumer side of things, and we ended up not having funding to go forward, and it was time for me to leave. So that's when I made my way back to IBM, started doing the biz dev stuff around the developer communities, and then was asked to go take a look at the quantum stuff, and the rest is history.
And that happens in 2017, right? The kind of introduction.
2017 was, yeah, December 2017. I went to the summit. Continued to work with them on sort of, whatever, a collegial level inside IBM. And then I actually took a role with the team in probably late summer 2018. So, yeah, less than a year later.
And
And
what
that
sort of
was
role did
to,
you take?
yeah, it was to build, it was to manage the strategic academic partnerships and the collaborations around like joint research,
Mm-hmm.
and to build out a programmatic way of building a community of researchers. So essentially, the first thing I did was other than things like the Chicago Quantum Exchange and other sort of large scale strategic relationships, but what I was doing was building up a program. Essentially, if you have a paper on the archive, you could get into this program that was, I think when I left, was several hundred researchers who had access to devices that weren't on the public cloud. So, IBM Q Experience, IBM Quantum Cloud, whatever it's called now, was a bunch of public systems, but the queue times could be enormous, right? There's hundreds of thousands of people using them all the time, just to, run something on a real qubit. So if you had actual scientific work to do, that could be really problematic. So we got them into this separate program. They had private access to, I think it was at the peak was like 7 machines. So, 7 machines in the 5 to 12 qubit range, but among several hundred users is a much better value proposition. And then in addition, I was sort of reaching out to individual researchers who I thought could do interesting things with new machines or new capabilities. So, for example, there was David Mazziotti at the University of Chicago as a chemist who I got him access to the 53 qubit machine. So he was the first non-commercial user who got access to the 53 qubit machine, so he could run a Bose-Einstein condensate simulation, which I thought was just a really interesting use case. I mean, I was trying to find ways to exploit these new devices that were still falling short of running Shor's algorithm or pricing derivatives or whatever, but had
Sure.
real scientific value. And that's still the place we're at right now, right? I mean,
Yep.
you can
Yep.
do really interesting science with these devices. So from my perspective, I was trying to find people who would say, well, that's an incredibly alluring lab instrument, rather than that's a really
Mm.
crappy computer.
Yeah, that's a good way of looking at it. Um,
Yeah.
so, how does that, how does that work? Do you get free reign to just go and pick who you want to offer time to? Is
In
there?
those days, yeah, I mean, I was spending time in the research community just as I am now, and talking to people, just asking them, what are you doing, basically? And when something's like David Mazziotti's had this story about thinking that he can, boson-Einstein condensates is what neutral atom devices were used for before they started computing with them. And he
Hmm.
said, so you can make a Bose-Einstein condensate in a physical device in this vacuum, with the laser-cooled atoms, and they're really cool. It's very hard to simulate that, and that's why we had to do it with these neutral atom devices. But I think I can do it on these superconducting qubits. And he did. I mean, he had figured out a way to do it. He thought, but he needed access to a large enough machine. So I went to Jay and said, here's what he wants to do. And he said, that sounds interesting. So I kind of would, I would go scout for an interesting sounding project and then bring it back to the leadership and say, is this interesting enough, or is it aligned enough with what we're doing? And I mean, I'm very, I see the sort of the evolution of that in some way to the emphasis on what they're calling utility computing at IBM over the last year. On the podcast, we interviewed Martin Savage, who did this great experiment last December on 112 qubits, where he simulated a Schwinger model, so one-dimensional high energy physics behavior in a Schwinger model that took, I think that his circuit depth was 370 or something, and he did something like the equivalent of 14,000 CNOT gates with air. He did it with error mitigation. So his problem, he could do very effective error mitigation, which allowed him to do many, many more gates. But that's great from like several different directions because it's interesting science. It's pointing the way to even more powerful scientific results. It's putting the hardware through its paces in a way that, stretches what you can do with the device, which is always useful from an engineering perspective. You want to see what
You
it
want to
can
know its
do, what it
limits.
can't do. Right.
Yeah.
It's like, get it out on the road and open up the throttle and see what happens,
Yeah,
right?
exactly. Yeah, exactly that.
Yeah.
Yeah, yeah, yeah.
Yeah. So that, I think I see. I mean, I don't know if they took that from the model that I started, but I see the through line there, right? It's a
Yeah. You can
continuation
see
of the
the
stuff I was
evolution
trying
of
to do.
what you started in
Yeah,
that sense.
yeah,
So, how do you go about then picking the? So, yeah, David, for example, how do you first hear about him? Are you just in the room somewhere and somebody says, you overhear a conversation, or are you actively doing research and trying to find these individuals?
yeah. It's serendipitous. I mean, I go to I went to, I think I went to QIP, Quantum Information Processing, in Boulder at the beginning of 2019. So just after I joined the quantum team in that role, and I sat in on as many of those talks as I could before I felt like my head was going to explode because it's way beyond my capability of understanding. But what I'm not trying to understand the math. I'm not, trying to be able to replicate those results or take them and apply them to something else. I'm listening for conceptual explanations, like what conceptually they're trying to do. Um, because as I said, those systems of understanding, whether they're linguistic or mathematical, they both have the end goal of trying to explain something, right? And so I listen for those little grains of conceptual framing, and then if it sounds interesting, I'll go talk to the researcher and say, tell me more. And that's where the current podcast kind of came out of that. It's like if I hear
Yeah.
something interesting or see, and I should say, I watch videos, I go to conferences, and I skim papers, but all of
Hmm.
it is very, as I say, conceptual level. It's not.
Yeah.
I'm not becoming a mathematician or a physicist by osmosis. Um, but there's some. I mean, you can also gauge sort of the excitement in the presenter as well, right? There's like something exciting they're doing, and obviously, if they're talking about hardware in any way, I'm like that makes my ears perk up. It's like, okay, what are you doing with these devices? Because that's what I find most interesting right now is, QIP. That first one I went to, there's maybe, I don't know, 500 participants, and I don't know, a week's worth of talks. So there's probably, 30 talks a day or something like that among all the tracks. Almost all of them start with something like, well, presuming we have quantum memory, or, with fully fault tolerant, thousands of qubits, we'll be able to do X, Y, or Z, right? And that I kind of tune out when I hear that kind of stuff. I mean, it's interesting, but it's still it's rarefied, it's theoretical, it's in the far future. If I hear someone talking about something they're trying to see if they can implement as a toy problem on NISC machines or whatever, then I start listening more carefully, because those are really creative approaches in general, right? It's like, you can't do the full-fledged theoretical thing, but you can do something. And if we can shoehorn something into this device, then maybe we'll learn more about the device, or we'll learn more about the problem, etc.
Yeah, and we'll push closer to that point of the
That's
fault
right.
tolerant machine, right? You
That's
need
right.
to keep
That's right.
yeah.
Yeah. Yeah. Or push closer to realizing value. What I'm realizing, I think it's really interesting. Like the last year, QEra demonstrated, or sorry, Misha Lukin and Vladan Vuletic demonstrated logical qubits on the neutral atom device in Lukin's lab, and that's going to be the next generation QEra device. IBM published a paper using LDPC codes to do logical qubits on a biplanar chip. Quantinuum demonstrated logical qubits. So there's this march towards logical qubits. However, I suspect that, like, we still have this kind of there'll be the transistor moment kind of thing in our minds, that there'll be this breakthrough, and after that we think we can already imagine what we're going to be using these things for once they realize that idealized state, right? I don't think that idealized state is actually necessarily either is necessarily end uh, destination. Like, as I hear all of these logical qubit demonstrations having, like, they're almost renegotiating what the definition of fault tolerance is in many ways, right? Like, because we don't know what we don't know. We have this theoretical idea of fault tolerance at scale and what you'll be able to do with it. The reality is, like, we're learning what we can actually build and how to build it, and what the really hard parts are and the easier parts. And maybe we put together a few easier parts and do something. It's sort of like, it's not quite fully fault tolerant, but we're increasing what we can do with these devices incrementally. And then at some point we'll realize, oh, we're doing all these really useful things with these things now. It's not what we thought we were going to end up doing, but it's really cool, right? Or
Yeah.
there's commercial value, and it's not what we anticipate. I mean, that's,
Yeah.
your firm is recruiting for life sciences. One of the things that's the most compelling to me about quantum computing, quantum technologies in general, is how rooted in the sciences it is still, right? It's not just a technology, it's not engineering. I like to say sometimes, people saw, whatever, the Apple Newton came out, or pick any sort of, rudimentary kind of mobile device. And it was like, well, it's not really any good, but we can see how in 5, 6, 7 years you're going to get the iPhone, right? And you get the iPhone, you go like, oh, there it is. Okay, now it works well enough. Fantastic. It's not that we're not in that engineering kind of evolution, right? We're
Yeah.
still in this curiosity driven. We do not know what is going to actually ultimately come out of this. We have to be very open minded and use a scientific approach to, test the hypothesis, disprove something, adjust, do it again, do another. It's all experimentation, I guess, is what I'm saying. And that I
Yeah.
find really exciting.
Yeah, no, completely agree. And I think, anybody who tells you they know what a quantum computer is going to look like is misled themselves or misleading you. Right. And I don't mean that to be, people have ideas, and we can all theorize on what things are going to look like, and that's fine. But
In fact, we have to.
Yeah, this is, and also to your point about applications, there are so many that we can talk about as potential, and there are some people who would tell you today that we have, at value, and we're providing application, and that's a whole nother podcast we could have in of itself, just about application for quantum computing. But I think there's a very real possibility that whatever the application is far beyond what me, you, or anybody else can think of right now. It could be something completely out of the blue, and it might just be the case. And this isn't, something that people necessarily want to say, but it might just be the case that quantum computers are good for simulating natural phenomenon, and that's the extent of the value. That's fine, and that's okay. But there's a real reluctance for people to, to have that discussion at the moment. And evidently funding plays a part in that, and venture capital coming into the industry. But
for sure. And we also don't. We can't say one way or the other, and that's the private sector has a hard time with that kind of unknowable ROI, right, and unknowable return horizon. That's why the public sector is so crucial at this stage, right? I'm very, very happy that there's something like, north of $40 billion now globally invested in national quantum strategies and national quantum initiatives. I think that's absolutely crucial, because this is a pure development play in some sense, right? It's like, we know we can build these devices that are beyond the thresholds that classical computing achieved. Like we're actually, we can compute with individual atoms now, which is like mind-boggling in and of itself. Yeah, I know. I know. And like the space program, right? Like getting to the moon didn't have any direct economic value, but like lasers came out of that, and all kinds of the satellite industry came out of that, telecommunications, et cetera, et cetera. Like if that's all that happens with quantum, great. you know?
Yeah, yeah, 100%. So I'm curious then, in terms of your role at IBM. So you started in 2017. You're there for 6 years, is that right? Six and a bit?
No, 4 years. So three and a
4
half, 4 years. Yeah, yeah.
Okay, so you're there for 3.5, 4 years. How does your role change in that time at IBM, and how do you see the industry changing alongside that? Because you've got your heart right on the pulse there, looking at trying to find application or value for quantum computers. So what does how does that change in the 3 or 4 years that you're with IBM?
Yeah, I mean, I think it's a really interesting, as I said, the book I'm writing is actually about the history of quantum computing. So
Okay.
there's this very interesting, sort of evolution of the sort of curious notion to, well, maybe there's a theoretical foundation to this, but you'll never be able to build these, to, well, maybe we can build these, but you won't be able to build at scale, to that 50 qubit machine that Dario was announcing in 2017 was almost 10 times larger than the I think it was, I think there'd been an 11 qubit machine, so maybe 5 times. It was 5 to 10
Yeah.
times larger than anything before. And at every stage there's this, well, maybe that's it, right? Like maybe that's as much as we can do. It seems so impossible. And I think it was, Ken Brown actually said to me something at some point, that every year he hears somebody say, "Well, that's it. We're not gonna progress anymore." And then the next year, like we've added another 9 onto fidelities or something that's so tangible, right? So it's, I mean, it feels like in that way, nothing has changed, right? For the entire history of the field. Like I remember my time at IBM, the same sort of thing. Well, the 53 qubit machine came out, but you can't really do anything on it. Oh, now we're bringing out a larger, a 65, and then a 100 and whatever qubit machine. There's this steady progress in certain ways, none of which kind of satisfy the skeptics. Um, but then they say, well, we'll wait and see what you do the next generation. And that iteration just continues along. So I guess what I'm saying is that there was this roller coaster the whole time of sort of like, uh, at that point I thought, naively, well, maybe this next one is the one that sort of crosses that threshold, along
Yep.
with the rest of sort of the outside observers. I think the biggest evolution over those 3.5 years is my own sort of understanding of just the enormity of the challenges that still lay ahead, and this more nuanced kind of understanding of like there's value out of each of these generations of devices because nothing like them has ever existed before.
Yeah.
So there's things we can do with these things that wouldn't have been possible at any point in prior in human history, right? So I guess what I'm saying is it's more personal evolution than what changed within IBM or within the industry.
Well, that's a good answer. Going back to what we said about education and how important that
Yeah,
is, that was clearly the thing that you took away from that. Uh, that kind of brings us nicely then onto your role at the moment within AWS. So
right.
you moved away from IBM. You've taken on this new role now. What is your kind of role encompass, and
Yeah,
your kind of day-to-day operations?
yeah, yeah. I mean, the thing that brought me to AWS is that same theme of wanting to learn.
Mm-hmm.
Um, the Amazon Bracket service is a multi-platform cloud service. So it's not one type of qubit. It's actually, we've got superconducting qubits from a couple different vendors. There's trapped ions, there's neutral atoms, if there are new and exotic types of qubits in the future, we'll have those on the service too,
I'm
which
sure there
is
will be.
yeah, and that's nirvana to me. It's like if there's a new
Mhm.
thing, we're going to get it on the service, and I'm going to get to talk to those hardware R&D people and figure out which researchers might be interested. I mean, the okay, so I'll take a step back. So the role is somewhat similar. I am actually business development and go-to-market strategy for quantum technologies, but I've been primarily focusing on the public sector. So university, academic researchers, public sector, national labs, these national quantum initiatives. And the go-to-market strategy is simple. It's providing researchers with access to a bunch of different really exotic devices, right? And then seeing what they do with it. Because in Amazon, there's this notion of like the service team. They're building the product, and then the go to market is an effort to find that product market fit and bring customer signal and market signal back to the service team, represent the voice of the customer, which is it's a nice mechanism that gets around some of the difficulty of a cloud service, right? Cloud service is sort of you're at arm's length and really you're building this thing that just abstractly sits at some remove from your customers, and it can be difficult to sort of get into the customer's shoes and really see how, what it is they're trying to do and how they are using the service. That's our role in the field organization. And so again, I'm hanging out with researchers and learning what they're doing and seeing how they might be able to use the service to access devices to actually drive their scientific research. So when we launched the QERA device in what was it? It was the fall of 2022. Is that right? Or 2023? The pandemic really messed with my sense of time. I think with
I think
everybody, right? It's
it's
like
22. I think, but
yes, I think that's right.
I think it's 22.
I think that's right. And that was super fun and kind of in a nutshell what I love about this role, because I talked to the QERA folks and learned about their technology and then talked with some of our applied scientists and other researchers around what could be possible with the way Bracket was going to surface that device on the service, which was as a analog Hamiltonian simulation service, not as a gate-based computer. So it was something I had to learn about. And then reached out to various members of the academic community. This is all pre-launch. So in the year running up to the launch, and sort of briefed them on what we were going to bring to market and solicited project ideas, and then helped the ones that we thought, okay, that sounds like a good fit. Let's do that in the private preview or the closed beta kind of period. And we worked with them, and I had researchers on our side working with the researchers in the universities, and Martin Savage was actually one of them. That's how I met him. So his group did a bunch of work, and as a result, when we launched the QERA device with this very novel, weird, exotic analog Hamiltonian simulation service, we were able to say, well, Martin Savage and these other researchers have done work on it, and this is the kind of work that they produced. And there's, I think the first paper hit the archive, with less than a week after the launch of that device. And then, that sort of, lit a little, signal torch basically to the rest of the researcher community to start thinking in terms of what could they do with that device, with that capability. And I, took whatever inbound calls on other proposals for projects, and have been helping facilitate those around the world now. So for a while, and that's that process will get repeated with every new piece of hardware. It changes from one to another. Maybe it's just a refresh. It's the same, same underlying trapped ion technology, but just more trapped ions, or maybe there's some new error mitigation in a new model or whatever. There's different levels of novelty, but in each case, it's sort of like go find the most curious, smartest people out there who can help us push the limits on what you can do with the device on the service. So that's basically, in a nutshell, that's what I get to do all the time, which is great.
Yeah, and I'm coming back to what you said earlier about wanting to continuously find that next challenge and trying to solve something, they're coming to you with those now. You've kind of
Yeah,
developed a position where those challenges are daily coming on your desk, so you
that's
no
right.
longer have to go out and look for them. That's a pretty good situation to be in.
Yeah, yeah, that's a good way
So
to put it. Yeah,
I guess one of the things that was really, when I was thinking about some of the things I wanted to ask and go through, you said one of the things that we've touched on a little bit is the parallels that you might have seen in your, various experiences from working at Apple right the way through to your roles as, CEO and COO of various new tech startups with different focuses. Are there any kind of like standout parallels that you think you can draw, or maybe trends is a better way of putting it other than direct parallels?
well, I mean, I think the the uh, the the value of curiosity and the importance of learning, right, and open-mindedness. I really think that you are diminishing your chances of success if you don't interrogate your own presumptions,
Hmm.
right? If you go into a situation in an emerging area thinking you know what is going to, what the right play is, what the right strategic decisions are, and you don't try to have that sort of, almost beginner mind, like pretend that you know nothing and sort of listen a lot, you're really really reducing. I mean, it basically means that your first guess is your only guess, and if you've got that one roll of the dice, and if whatever comes up, that's what comes up. Like that seems like a very very high risk way of going into an unknown space or a new space. So yeah, curiosity and learning, and then again, sort of the on the organizational side of things, hiring people who are smarter than you and letting them follow their own curiosity and their own desire to learn and problem solve, right? I think top-down micromanagement is death for innovation in every way you could possibly imagine, because you're not going to be able to retain the best people for those types of roles if you're doing that. um, and then, I guess this goes with the original point. The thing to keep in mind is, like I said earlier on, like, draw analogies, right? History doesn't repeat, but it does rhyme. Don't look for one-to-one correspondences, but keep a historical perspective in mind, because there will be dynamics, or when you're thinking about possible scenarios, you can draw on parallels from the past and other scenarios, other situations, to help inform, like, what's possible in this kind of situation, right? And there are patterns that repeat for sure. It's just you have to look past the surface and not over identify with the surface reality, but try to draw the connections at that deeper, sort of more conceptual level.
Yeah, understood. I think that's a very good way of putting it. And you're right. It's about just digging a little bit deeper,
Yeah,
and really making sure that you're looking at the whole picture.
yeah.
Um, I guess, how does the general direction of quantum kind of relate to, and I'm deliberately being quite broad here, but how does that general direction that quantum's heading in at the moment compare to the kind of further, if you will, that the dot-com bubble and the rise of the internet had? Can you draw a comparison between the two? Do you think they're on a similar trajectory?
um yes and no, right? So there's a risk that we overhype things, which I think
Mhm.
certainly happened during the dot-com boom, right? I mean, there was, I remember a company filed their S1 to go public, and we were reading it, a friend of mine and I, and there was a direct quote that said, with the current business model, we do not foresee ever being profitable. And that was that was their S1 filing.
Yeah. Yeah, that seems like a fallacy. I feel like you might want to readdress that.
maybe maybe keep drafting that one before you file it, guys. Um, so there's that kind of, um, if you build it, they will come kind of mentality, which I think is never healthy, right? You have to focus on incremental creation of value and realistic timeframes. I worry that there's been some overinvestment in the public sector or private sector. I do think the public sector is kind of counterbalancing that. So overall, I don't think it's that much of a risk. but I think that's important for everyone involved to keep an eye on. And so, uh, it's interesting because in a way, the internet seemed like too simple to be this important, right? I mean, it was, there'd been all these attempts to do client server, distributed applications in the enterprise before. Whatever, IBM had SNA, PS, I think, or SNA, and Microsoft had RIP, I think. They all had these enterprise application protocols for distributing enterprise applications globally, right? They were all really complex, which is why they didn't work. And HTTP came along and HTML, and they looked like a crayon drawing of a networked application, right? I mean, it's like, is this some child do this, right? I mean, I remember the application engineers just being horrified at how simple it was. But that was why it was able to have such a broad adoption and huge impact. It's kind of the opposite with quantum, right? I mean, if you try to simplify it, it's certainly not going to work. I mean, it's any attempt to diminish the complexities of what these scientists and engineers are trying to pull off is going to fail, right? Because it's from that perspective, it really, again, it has way more to do with fundamental science than, sort of network and communication and computer engineering, which is really what the internet was. The internet was kind of inevitable in a sense. So that's different. And the thing I think is similar is that it's, I remember seeing the first URL on a billboard, right, and thinking that's weird. I wonder, how broad is the impact going to be? It was really difficult in 1997, right? The IPO of Netscape. It was like, why is this such a big deal? I don't understand. And now, like, literally no business exists without some kind of internet involved in it, right? I mean, unless you're like handcrafting wooden stools or something, I guess you could still have a website though. So,
Well, to bring that point kind of full circle, my partner's an artist, and even she paints by hand, and it's all she does. She uses Instagram, like
yeah,
you said.
right.
She's an artist and she's at home, and that's.
Yeah,
But every business relies on the internet,
that's right.
even ones at that level. So
That's right. That's right.
it has
Yeah,
become.
and so I don't think anybody could have in 1997 or even 2000 really anticipated just how broad and profound the impact of that set of technologies was going to be. And I think we're in the same kind of situation where I can make guesses, but I know I'm wrong, right?
Mhm.
It's too much of a, there's too much unknown about it to be able to extrapolate. And
Mhm.
so whatever your best guess is, know that it's wrong. And that's also, I think, similar to the early days of the internet. It's like, go ahead, you got to try, you have to have a hypothesis, right? But it's almost 100% certain to be completely wrong.
So yeah, but that hypothesis, they're meant to be tested,
That's
and
right.
when they go wrong, that's never a problem,
That's
because
right.
you write another hypothesis and you
That's
test
right.
it again, and you go and so on and so forth. And I want that that mindset to stay within quantum.
Yeah,
My fear is that as we commercialize, which inevitably we will do, and we'll start to push more and more towards application, I think we need to remember that, and that the
yeah,
fact that even if there's application today, there's still so much further we've got to go. And it's
that's right.
important to not lose sight of the fact that we're still, in an R&D phase. I think it's fair to say there's
Yeah,
engineering to be done, and there's engineering that needs to happen. And that, I'm speaking out of turn here. I'm not a physicist, as you said. I'm not. They're definitely not from osmosis. But that's just my general feeling, and I
yeah,
think it's important to remember that we're still at R&D. We need to stay with that mindset, and
that's
if
right.
we continue to innovate, applications will come, and they'll become more
Yeah,
obvious.
that's right.
It won't. You won't have to search for them because they'll be there in plain sight.
That's
Whether
right.
they're something we think of now, or whether we think that they could be, as we said earlier, something completely different.
That's right. That's right. Yeah, and I mean, I think at the foundation of this field is, what Feynman put so succinctly at the Endicott conference in 1981, which is, if you want to simulate a natural system, they're quantum, so you need a quantum system to be able to simulate. So even, the most capable machines we're building today are essentially physics experiments, right?
Mm-hmm.
They're quantum physics labs that can sit in the cloud, and you can connect to them anywhere in the world, and you can
Yeah.
run an experiment and you can test your hypothesis. So like they are science machines
Mm-hmm.
at the core of it.
I think that's a great point to end on.
Sure.
I think that brings us, very much full cycle. So, yeah, look, Seb, I really appreciate your time. I think you've got
Thanks for
a
having me.
fascinating background, and no, more than welcome. It's been a pleasure. So, just to recap, you've got your own podcast, which is
The new
the
quantum
new,
era.
yeah, and that comes out weekly,
Yeah,
most weeks.
mostly. Yeah.
You're writing a book at the moment. I don't think you've given the title away yet, but you said it's about the history of quantum
It's called
computing.
the new quantum era.
It's called the. Well, is there a kind of estimate for publication on that? How
Yeah,
far along are
it's with O'Reilly Media. The first 10 chapters are going to be live on their digital platform this July, and then the physical book and the rest. I think I haven't decided whether it's going to be 15 or 16 chapters, but it's basically part three, and the first two parts will all be in a physical book in January 2025.
Well, I very much look forward to that. Sounds like something for the Christmas list.
Yeah.
Seb, thank you
Awesome.
very
Thank
much.
you,
Have a
Connor.
good day. We'll
Thank
speak
you.
soon.